test 3 review. Part 1 of the test is just like last time. It's multiple choice, 25 questions. You want to review the TYKs, so TYK 7, 8, 9, and 10. Some of the questions, when you go back to those TYK, some of the questions are asking, is this a significant finding based on the SPSS output? If the P is less than 0.05, then it's significant. So if you get, like if the two-tail P is 0.07, not significant. 0.03 would be significant. Some of the questions, it's like, is this a one-tail or a two-tail? And you can tell the difference between that in the SPSS output because the confidence intervals. If it says 90% above the confidence intervals, that means we switched it to a one-tail. So if you're looking between the one-tail and the two-tail, look at those confidence intervals. If it's set at 95, look at the two-tail P. If it is set at 90, look at the one-tail P. Part 2 is fill in the blanks, probability, and then our t-test. So the one sample t-test, independent samples, and the paired samples t-test. You can use the Google Sheets for that. And then also in this review, I put in all of the SPSS stuff just for, so there's the one sample t-test, the independent samples t-test, the instructions in SPSS, and then what the output looks like, and then for the paired samples as well. So this review document's pretty good because you don't have to, some of the PowerPoints get really long, especially with like all the math and all that stuff. But at the end of the day, you just need to be able to run these analyses. And so I put them together in one PowerPoint, which should be helpful. I'll do the probability stuff last because I think most people are probably interested in the 3 t-tests that we'll do. And so in the first one, open up the save file. First column is views of YouTube videos. For this type of video, the average amount of views is 113. We are not sure if views for these videos will be above or below 113. And since we're not sure if it's going to be above or below, it's going to be a two-tail test that we're going to run. And so let's go to the data set. This is views. It looks like it's probably higher than 113. Is it significantly so? Not sure. So compare means, one sample. We move let me reset it. Move views over, and then you got to change the test value to 113. If you don't put in that test value, it's a completely different analysis, a completely different output. So make sure to put in the test value. Click OK. We get that is our output. Let's go back here. So YouTube videos were higher in our sample compared to the population estimate. So you get your mean right up there, 118.00. You have to have the leading and following zeros. Last time I fixed a few that did not have them, but I don't plan on fixing them this time because it's the third time we've done this. Standard deviation, 5.78. The difference, the mean difference right there, 5.00. Our confidence intervals, 1.66 and 8.34. What's significant? Our degrees of freedom, 13. Our value for T, which is 3.24. You see that the 13's there. The 3.24 is right there. And our p-value, we said we were doing a two-tail. It's 0.006. So the closest we do it by 0.05, 0.01, or 0.001. This one is going to be under 0.01. Whoops. And then, yeah, that's it for that one. Not too difficult. The next one, let's look at it here. Group and happiness. And so imagine we expose a group to a happiness intervention. The control group does not receive this intervention. This is an untested intervention. So we've never tested it before. That means it's going to be a two-tail test. This first one, when we are comparing our sample to a mean, that is a one sample t-test. If we are comparing two different groups, so in this one, we have two groups. We expose a group to a happiness intervention, and then there's a control group that does not get it. Happiness group, control group, experimental group, and control group. So it's two groups that we're comparing to each other. They're independent of each other. So independent samples t-test. That's part of it. You got to be able to pick the right analyses. And for this one, you need to be able to tell the difference between a one sample individual. You need to be able to tell the difference between a one sample t-test, independent samples t-test, and the paired samples. So if we go back to our data set, and you can see it, happiness and control. So that's happiness is, 1 or 2. Well, we can just look at it. If we click view, take the value labels off. That group's 1. The other group is 2. So happiness is 1. And then this is levels of happiness. So if we click analyze, compare means, once independent samples t-test, we're going to move group to grouping variable, click define groups. You can just leave it like that. If you wanted to, you could put 2. You could put group 1 is 2 and group 2 is 1. And then, that would change the mathematics. So if you're trying to get a positive number or negative number, you could switch those, or you can just mentally switch them too. Continue. And we do not have to click options for this one. We do need to put happiness as the test value and put that over there. Click OK. Okay, so happiness in the intervention group. And so it does say happiness is a 9.38. Standard deviation of 1.19. And then our mean for the other group, quite a bit less, 4.88. Standard deviation, 1.55. That mean difference, you have to go in the independent samples test part, and we'll have to scroll over a little bit. Mean difference, 4.50. Our confidence intervals, we have 3.02 and 5.98 is significant. Our degrees of freedom, first, our value for t, 6.51. Our p-value is less than 0.001. And then our value for d, really big. So Cohen's d, the point estimate, 3.26. That means that this data set probably has almost no overlap between the two. So if we look at happiness, everything is above a 9. The lowest one's an 8. And then for the control group, there's not even the highest one for that's a 7, meaning that these distributions don't even overlap on one number. So those two distributions are completely separate. And if you remember that image for Cohen's D of 3.00 basically says that, there's going to be, they're completely two different distributions. Before I move on to the next one, I forgot I should have done the other ones in Excel sheet. So for one sample t-test, all you have to do is take that data there. You can press Control-C to copy it over to the one sample t-test right there. Press Control-V, it'll paste it over. And that gives us, we gotta make sure to change that test variable, 113. So look, just if we don't change that test variable, let's just say if we left it at 0, I keep saying that if you don't change it, things are really different. So if we leave it at 0, that means we're comparing our mean of 118 to 0. And so that gives us a t-value, a huge t-value of 76. So that doesn't make sense. So our test variable, if we put in 113, now our t-value goes to what seems like reasonable t-value of 3.23. And all these numbers should be the same. And again, we are doing the two-tail. You can see here at the side, we have the two-tail, our upper and lower. And at least for the one sample, I figured out, and you could copy this over if you wanted to, there's this formula that tells you the exact p-value to enter. So for this one, that 0.006, p less than 0.01. On the independent samples, so if we look at, so these are they're not, I don't know why I did it like that, but we should probably sort them. For right now, I'm just gonna move them over. So happiness, group 1, we'll copy that part, we'll put that right there, and then we have two other numbers, a 9 and an 8. I'll just enter those, 9 and 8. And then for our control group, we'll copy those. Enter those for group 2, and what was the other two? A 3 and a 5. 3, 5, and then you can just clear those other numbers out. If you can get them like that, and then you delete cells and shift up. And there we go. Same thing that we had in SPSS, so our t-value 6.51. There it is, t-value 6.51. Our ends, the means for each group, everything's the same. So this sheet works really well. I'm proud of it. What's next? Okay. Test 1 and test, so we're using test 1, test 2. Imagine a driving test to 15-year-olds that have no training or experience driving a car. Then we give each participant a semester-long driving class, and then we retest each participant on the driving test. Report as positive numbers. We have no previous research on this driving class. Meaning that because we don't have any previous research on this, we should probably run a two-tail. We don't know if this is a good class or not. Is it possible that it could be a bad class and they actually drive worse at the end of it? It's possible. When I was a kid, my driver's ed class, who taught that class? The football coach. It's like, come on now. And it was not good. It doesn't matter. This is a two-tail because it could be a bad class. If it was like a class that's been taught a million times, the instructor's really good, has good evals, then it's like, okay, yeah, you would do better from test 1 to test 2, the pre-test to the post-test. And because it's two different tests with the same people, Pre-test, post-test, this is going to be that paired samples t-test. Look at the data set. Test 1, test 2, analyze, compare means, paired samples t-test. And then we're going to move test 1 over and then test 2 over. Okay, I'm going to reset that. I know that they scored higher. I can look at it. You can too. So test 1, you can see the average is probably a 50 something. And then for test 2, the average is probably a 80 something. So we know that test 2 is going to have higher scores, and it does ask you to report them as positive. So I'm going to put test 2 first to give us those positive numbers. We leave everything else alone. If we did need to change it to a one-tail, we click options, and then we change that 95 to a 90, but we're not going to do that in this one. Click OK. And then, yeah, so because I put test 2 first, we are going to get positive numbers. The mean difference between test 2 and test 1 is about 40 points. If you had test 1 first, it would be negative 40 points. And could you just switch that in your mind? Yes, you could, but I don't know. I kind of like seeing it like that. But in any case, the pretest scores are 47.50 with standard deviations of 6.58 and 88.20 standard deviation. I messed those up. So 88.20. The standard deviation is 6.58. The standard deviation on this one is 14.39. I did that the other day too, and I noticed somebody else did it on the quiz. Make sure that you're keeping that 88 with that standard deviation of 6 and the 47 with the standard deviation of 14. So the difference of, we get that from here, 40.70. I'll have to check what that other space is for. I think it's a typo, but I'm going to put this in for now. Then our critical confidence intervals, we see those right there in the middle. So 31.19 and 50.21. And so what that's saying is we have a mean difference of 40.7. We think if we ran this experiment 100 times, that 95% of the time it's going to be somewhere between the mean difference, somewhere between 31 and 50. Our T, degrees of freedom, scroll over just a hair, 9. And our value for T is 9.68. And our p-value is less than 0.001. I'm pretty sure. Let me double check it though. Yes. And then our value for D, same thing with last time. It's a pretty big difference. These distributions are completely different from each other, 3.06. And so that is the 3 analyses: one sample t-test, independent samples t-test, and the paired samples t-test. This number should not be here. I'll at the end of it, we'll go see it's some kind of a typo. We'll see what it is at the end. If that was all you're interested in, great. If you need to hear about the probability, I'm going to do those as well. If you randomly select one applicant, what's the probability that they're between 700 and 749? So there's our total, 60 and 6. So that's going to be 0.10. Also, let me get my calculator for the next ones. No leading 0. You do have the following 0 though. Randomly select between 600 and 699. So you're going to add 4 and 5 to get 9. 9 divided by 60 gives you 0.15. What are the chances of picking 2 students in a row from 500 to 549? So it's 12. So 12 divided by 60 is 0.20. You take 0.20 times 0.20 to get that number, and it's 4.04. Again, you just take that number, 12 divided by 60 gives you 0.20. And to do it twice in a row, that's the multiplication rule. You take that 0.20 times 0.20 and you get 0.04. Okay, we have students, 250 students in a Brazilian Jiu-Jitsu class. 170 students are in person. Of those, 150 passed their belt test. The remaining took classes online, and of those, only 40 passed their belt test. And so you'd need to kind of create a table that looks like this. I'm going to do it in Excel. Okay, so our total is 250. We have 170 are in person. So in person total right there, 170. And of those, 150 passed. That means who took it online? It's 250 minus the 170, which is 80. And then let's see, only 40 passed their belt test in that one. So 40 passed, and then that also means 40 failed because 40 plus 40 gives us the 80. 40 plus 150 gives us 190. And then, so if this is 150, this is 170, that means that's 20. If you go 40 plus 20, that gives you 60. And then if you've done everything correctly, 190 plus 60, that'll equal 250. What is the probability of randomly selecting a student that passed the test? So we'll go over here, 90 divided by 250, or 190 divided by 250, 76. So 0.76. What's the probability of selecting an online student? We go to the online, we go to the total, which is 80. 80 divided by 250. We get a 0.32. Conditional probability. Okay, given that they took the classes in person, so that's going to be our total, that's our denominator, who passed. So that's going to be passed divided by that total, 150 divided by 170. We're getting 88. And then an online student that failed the test. So online we have 80, failed 40, so it's 0.50. Okay, and then yeah, that's it. I don't know how long that's taken me to do. 18 minutes explaining it at the same time. I think if I was to do it without explaining it, I think it would literally take about 5 minutes. So some people will finish really quick on this test, and then, because it's not even that many questions, to be honest. Some people won't. Some people need the entire hour. I'm going to click submit. I'm going to miss one as my guess because of this, whatever this typo is. But let's see. Okay, I missed that one. Pretty sure that was 0.50. I'll double check it here in a second. Okay, yeah. Oh, I was supposed to be the 95. No, I don't want that to be there. I'll take that out. Yeah, that is a typo on the key because I just went back and rechecked it. And so it was supposed to be 0.50, but that happens. Who knows why I did that. I'll go in and change that, and I'll also take out that 95 because that's just, that even tricked me. I don't know why I did that. And so yeah, I think that's it. If you have any questions, I'll probably go over all this in class as well. I'm going to go ahead and post this video probably today, and we'll go over it in class. And I think most people will do pretty well. I would not be surprised if we have an average of an A on this test. All right. Thank you for listening.